Okay, great. Let's continue where we left off. In our previous video, we obtained the drift and standard deviation values we will need for the calculations of daily returns. The type function allows us to check their type and see it as pandas series. To proceed with our task, we should convert these values into NumPy arrays. You already know that NumPy's array method can do this for us. However, let me demonstrate how typing dot values after a pandas object, be it a series or a data frame, can transfer the object into a NumPy array. You see, we obtain the same output for the drift as we did with NumPy.array. Then stdev.values provides an analogical output and allows us to obtain the standard deviation. Great! The second component of the Brownian motion is a random variable, z, a number corresponding to the distance between the mean and the events, expressed as the number of standard deviations. SciPy's norm.ppf allows us to obtain this result. If an event has a 95% chance of occurring, the distance between this event and the mean will be approximately 1.65 standard deviations, okay? This is how it works. To complete the second component, we will need to randomize. The well-known NumPy rand function can help us do that easily. If we want to create a multidimensional array, we will need to insert two arguments, so I'll type 10 and 2. Here you go. We obtained a 10 by 2 matrix. We will include this random element within the PPF distribution to obtain the distance from the mean corresponding to each of these randomly generated probabilities. The first number from the first row corresponds to the first probability from the first row of the X matrix, the second element to the second probability, as shown in the X matrix, and so on. Great! The whole expression corresponding to z will be of the type norm ppf open parenthesis numpy random rand open another parenthesis 10 and 2 close all parentheses. The newly created array used the probabilities generated by the rand function and converted them into distances from the mean 0 as measured by the number of standard deviations. This expression will create the value of z as defined in our formula. Cool! So, once we have built these tools and calculated all necessary variables, we are ready to calculate daily returns. All the infrastructure is in place. Okay, so first, I would like to specify the time intervals we will use will be 1,000, because we are interested in forecasting the stock price for the upcoming 1,000 days. Then, to iterations, I will attribute the value of 10, which means I will ask the computer to produce 10 series of future stock price predictions. Okay. The variable daily returns will show us what will equal e to the power of r. We discussed this in the theoretical lesson, remember? We will need NumPy's exp function, which means we are calculating Euler's number e raised to the power of the expression written between the parentheses. In the parentheses, we will have the value of the drift and the product of the standard deviation and the random component, created with the help of the norm module. Its percentage value is generated with NumPy's rand function, using time intervals and iterations specifying the dimensions of the array filled with values from 0 to 1. Great! So, the formula we used in the previous cell would allow us to obtain a 1,000 by 10 array with daily return values, 10 sets of 1,000 random future stock prices. Great! We are a single step away from completing this exercise. We'll do that in our next lecture. Thanks for watching.